Want to know why it smells so good? Diffusion with the perfume.
Baily, it smells like coffee in here.
Yeah, I'm just putting some sugar in here.
When stirring the coffee, the sugar diffuses into it.
Today's topic is diffusion and osmosis. To start off, what is diffusion? Diffusion is the net movement of particles from an area of higher concentration to an area of lower concentration. During diffusion, molecules will undergo passive transport, which does not require energy. In this diagram, we will be looking at molecules of dye diffusing into water and eventually reaching equilibrium. The molecules will cross over the membrane from a higher concentration to a lower concentration, which is called diffusing down a concentration gradient. The concentration of the solute molecules will eventually reach equilibrium. Once equilibrium is reached, the molecules will continue to cross over the membrane but at equal rates in both directions. So what is selective permeability? Selective permeability is the property of a membrane which allows some materials to pass through while keeping others out. In the diagram, the dotted lines splitting the sides in half represent a selective permeable membrane where molecules can move side to side.
I'm pouring water into the plant. This is an example of osmosis because the soil is absorbing the water.
So right now I have an IV in my arm. And this is an example of an isotonic solution because the saline in the bag is the same concentration as in my body, so it's not harming or affecting my cells. I'm making pasta and putting the pasta into boiling water. This is an example of a hypotonic solution because the water is going into the pasta, making it expand.
Okay, so this is an example of a hypertonic solution because after doing the dishes, I hang the towel over the sink so the water's being evaporated and the towel's losing water.
On to osmosis. Osmosis is the diffusion of water molecules through a selective permeable cause. Osmosis can affect cells in 3 different concentration types: isotonic, hypotonic, and hypertonic solutions. And the first solution is an isotonic solution. An isotonic solution is a solution in which the concentration of the dissolved substance is the same as the concentration inside the cell. This means that water is entering at equal rates and therefore the cell is normal, remaining the same size. The next solution is a hypotonic solution, which is a solution in which the concentration of the dissolved substance is lower than the concentration inside the cell. This means that more water is in the cell, causing it to burst, or in more technical terms, to lyse. The last solution is a hypertonic solution. This means that the concentration of the dissolved substances is higher than the concentration within the cell. This means that more water is outside of the cell, causing the cell to shrink, or in more scientific terms, causing it to shrivel. This is all we have for you today on diffusion and osmosis. Thanks for watching.